Okay, let me show you a trick for number one. And I know, sadly, that they do a lot of this kind of question on the ACT simply because people don't choose answers. So they like this kind of question. Okay, so on number one, it says there's a hint at the bottom that says something about a unit digit of 2401 is 1, which means if we have the number 2401, the last number is a 1. That's all that means. So if we go look back through all of these, we see 1, 7, 9, 3. And then again it happens 1, 7, 9, 3. And then again it happens 1, and you can bet the unit digit on 7 to the 9th is going to be a 9. And the unit digit on 7 to the 10th is going to be a 3 because it's making this pattern over and over again. 1793, 1793, 1793. It's going to continue. Now, you have a couple options. Could you sit there and list all that out? Yeah, you could. But we've talked about you don't have that much time on a standardized test, so this seems like a bad option. Hopefully there's a better way. Regardless, you know it's not 4. And even if you hadn't noticed there was a pattern, surely you noticed all of these were odd numbers. 49's odd, 2401's odd, all of these answers were odd. So there's no way we were going to pick the even answer. So we were going to guess 1, 7, 1, 3, 7, or 9 to begin with. So we just got to figure out 7 to the 50th. So I could continue listing this out to figure out 7 to the 50th. And if I had a lot of free time at the end of the standardized test, I would do that. I would rather spend 5 minutes and get at least for sure that one correct than just lay my head down and take a nap and not get any extra points. But for being really smart about it, we notice it's repeating every 4. 1793, that's 4 numbers. 1793, that's 4 numbers. So the pattern is 4. So let's see how many times does 4 go into 50. And the reason I'm doing 50 is because they asked for 7 to the 50th. So 4 goes into 5 one time. I have 1 left over. 4 goes into 10 2 times. And I have 2 left over. Okay, so either it was going to divide evenly, and I was going to have a remainder of 0. If it had been 4 to the 48th, for instance, it would have gone in 12 times, and my remainder would have been 0. In which case, I would have looked over here, and my answer would have been 1. Let me zoom out. It was going to divide and have a remainder of 1, so my answer would have been 7. Or it did what it did in our case. We had a remainder of 2, so our answer is going to be 9, so the answer is E. Or if it had been 51, 4 into 51, it would have been 12 with a remainder of 3, in which case we would have gone with the third. And then it starts all over again. So if we notice how many are in our pattern, so we had 4 numbers in the pattern, 1, 7, 9, and 3. We divide 4 into the digit it wants to figure out the remainder. And that's how we're figuring out the term is 9. I guess that's really complicated and crazy, but now that you've seen it, if the pattern was 3, you would divide by 3. If the pattern was 5, you would divide by 5. You just got to figure out how many are in the pattern and divide that into there. The remainder helps you know which one to go with. Since our remainder was 2, we're going with 7 squared, which is a 9 at the end. So we're going with E, which is 9. When I walked around, those who didn't have blank had either guessed D or E. So look at you. You either guessed into it or were really close to it anyway. Okay, number 2 is an awesome question. Here's the issue, though. No one in this room has had a stats class. No one in this room has had a stats class. This is called a frequency table. I think they even tell you that. They do. Relative frequency. It's a relative frequency table. So, first of all, it's something you've never seen before, so you probably got frustrated and stopped. There's no need, though, so let's read through it. On a given day on a certain poultry farm, the relative frequencies of chickens, ducks, and geese that laid an egg or did not lay an egg are given in the table below. 2 of the relative frequencies are given by letters. If it can be determined, what is the sum of the values of A and B in this table? Whatever you did, I hope you didn't pick E, because we can figure it out. Although sometimes that is the case. Okay, if you guessed, which 2 letters would be the best guesses up here? There are 2 really good guesses.
C.
Or
A.
C or A. Notice 1919 happened twice. And the real answer is one of those two answers. The real answer is D. So David just guessed into the real answer. Perfect. You're awesome, David. Okay, how David worked that out, let me show you very quickly. Notice that each row is adding up to a total of 1. So 33% didn't lay an egg. How many percentage did lay an egg? It has to add up to 100%. So I need to know what number to put in for A. 0. What? Yes, 0.67 is correct. Okay, so 67 plus 33 does add up to 1. And even if you were thinking Miss Compton's crazy, the ducks line is filled in for us, and 45 plus 55 is 1 as well. So, okay, and then what number do I fill in for the geese? 52. So if I add those two numbers together, 0.67 plus 0.52, it adds up to 1.19, which is the correct answer of C. But even if David hadn't worked it out, he understood that the answers are showing a pattern anyway. He could probably guess into the answer. Just because it says it's a frequency table or something that looks like it's stats doesn't mean you can't do it. Most stats problems are actually the easiest ones because it's just about you reading a table. You can read the table. That's easy. Okay, if you've got that done, go ahead and get out some colors. I put some on your table. You're going to need at least 4 to start off with. We're going to color on those notes you just picked up on the pudding. Yes. So I know we passed out some notes from last week. We're actually not going to get to this maze until tomorrow. It might not even be until Thursday. So we're going to hold off on the maze. The maze involves numbers. We're going to hold off adding numbers until we got the angle relationships down. So hopefully we'll get back to these 3-1 notes today. First period didn't, but first period also had like the longest announcements ever. So, you know, it's not first period's fault. You're going to need at least 4 colors for now. Maybe more. Okay, so we're starting on a brand new chapter. The first thing we need to know about is a parallel line being cut by a transversal. Let me pause while y'all get ready. Let's go. So our new chapter, the first 2 sections are on angles. Why am I talking over you? The first 2 sections are on angles. We need to learn about all these new angle relationships. We already learned about 3 different angle relationships back in 1.4 to 1.6. Do you remember those terms? One started with a V, one started with an A, one started with an L. And? Linear pair. Perfect. So those are going to come back into play, but we've got to learn about some new angles as well. The first thing we're going to talk about today is a transversal. A transversal is a line that intersects 2 or more lines at different points. So I'm going to color this thing yellow. It is a transversal. It is crossing 2 or more lines at different points. Notice that in our case, those lines are parallel. The lines have to be parallel and they have to be cut by a transversal. Okay, I'm going to go ahead and color in all my transversals, just so I know from here on out those are all my transversals. Now, I've drawn on the board and I'll draw it on my paper too. Today it's going to be fine and I'm not going to make life super complicated. But the parallel lines are not always going to be horizontal like this. Sometimes they can be vertical parallel lines cut by a transversal. And so then we still have to, they're still going to have the same angle relationship. So just be prepared. I know we're seeing these 2 pictures today, but these 2 pictures are coming. So the angle relationships that we find out about work on these are still going to work here. Okay, the second box says 2 angles that lie on the same side of the transversal are in corresponding positions. So I'm going to write out to the side. This is for corresponding angles. Now I say, this is really silly, when I always sleep at night, I sleep on the top right spot of my bed. That is where I sleep. That is my spot. So if I go to a hotel, I'm still going to sleep on the top right spot of that bed. I am. So corresponding is like sleeping in the same spot in your bed. So my cat sleeps on the bottom right. He's the black ones. Let me zoom in so you can see my colors. I need to do that a different color. I'll do that blue. Grant. Can you see the purple and the blue?
No.
No? Okay. Can you see it's like really ugly then?
Yeah.
Okay. Thank you. And then let's do the others. There's more. Of course, my husband sleeps top left, but whoever in your imagination can sleep top left. It can be you. You can take up the full bed. I don't care. And then, of course, my dog sleeps bottom left, and this is not actually true at all, but it works for our example. Corresponding always happens in the exact same spot. Bottom left, bottom left. Okay, so bottom left, top right, bottom right. Those are all corresponding angles. We have 4 pairs of corresponding angles. Are there any questions on corresponding? Okay, the next thing we read says interior angles that lie on opposite sides of the transversal, and this is going to be for interior, and I'm going to abbreviate interior. And it's actually alternate interior angles is the term we use. And normally I abbreviate alternate ALT just to make my life a little easier. Okay, interior angles that lie on the same side of the transversal. So I need to somehow color that in over here. What do you think they mean by inside, by interior? Between the 2 parallel lines. So I'm going to actually draw it out to make sure we've got it for today. This blue area, we're going to call it the interior. What's the term we use for the stuff out that's not interior? Exterior. So I'm gonna write the word exterior a ton of times. You don't have to. I'm over exaggerating, I know. So if we're between the 2 parallel lines, we are on the interior. So it says interior angles that lie on opposite sides of the transversal. Opposite sides of the transversal. So if I'm here, I'm on the inside. My opposite interior would be there. You can use colors. I'm going to go to a shape now just to try to help Granite. I hadn't forgotten all about that. If I am here, my alternate interior spot would be there. I'm inside, and I'm on opposite sides of that yellow line. Alternate interior. The circles go together and the X's go together. You can use 2 colors. Are there any questions about the alternate interior? Okay, well, if you're already in a color mode, you can go ahead and color ahead. You know, if we're going to do exterior, I'm going to color the same thing again. Interior. Interior. Exterior. 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 Okay, so now I'm actually going to read. It says exterior angles that lie on opposite sides of the transversal. So they're on the outside and they're on opposite sides. They're on the outside and they're on opposite sides of that yellow line. And we call that exterior, alternate exterior angles. We call that alternate exterior angles. Okay, so big giant review. For the past 3-4 minutes tops, we've learned so many new things. That yellow line is called a transversal. It's cutting between 2 parallel lines. If they are in the same spot, the way I sleep in the same spot on my bed, they're called corresponding. If they're on opposite sides of the yellow line on the inside, they're called alternate interior. If they're on opposite sides on the yellow line on the outside, they're called alternate exterior. Are there any questions about that? Okay, well, obviously we still have a little more to do, but I'm going to say the next two are a review. I'm going to call them repeat because it's stuff we've talked about before. And you're going to draw like a separate box. Those are repeat. Repeated. We've done them before. It's something you already know. For instance, two or more angles whose sum is 180 degrees. What do we call that? Exactly. So supplementary angles. Now, let's see. If I do this one with one rainbow, and I do this one with two rainbows, well, we know the purple plus the blue adds up to 180 degrees. They're supplementary. What's more annoying, though, is if you know that purple, you know this is a vertical angle, so it's purple. The blue has a vertical angle as well, so it's blue. So if I just tell you a number for the purple, you can fill in all the purple slots and all the blue slots just like that. And after tomorrow, once we learn more about these alternate interior, alternate exterior, and their relationships, once I give you one number, you'll be able to fill in everything. One number is all you need, and you can fill in all the angles in this picture. In fact, I'm going to go ahead and be crazy now. There's a purple there. There's a purple there. We'll talk about why it's purple tomorrow. Blue here, blue here. I can fill in that whole picture. Okay, the next one says two angles whose sides form opposite rays. Here is an opposite ray. Part of this angle that I've colored orange. No. Here is an opposite ray. It's part of the angle that I colored green. Together, that green plus that orange, they add up to 180 degrees. What will we call this green angle and that orange angle? What's a vocab term we know for this? They are a linear pair, and my picture got ugly, so I'm going to draw it again over here. Green plus orange made that line, and we called that a linear pair. Very good. Okay, and then our last new one says angles that lie on the same side of the transversal between two lines. So same side of the transversal between two lines means they're on the interior. So if I draw my areas again, interior, interior, exterior, exterior. So same side of the transversal between two lines. So that means they're on the inside and they're on the same side of the yellow line. So those two X's go together and these two circles go together. Notice those words same side. So we're going to call them same side. Interior angles. But there's another vocab term. So, and what's really annoying is we did same side interior today. There's also a same side exterior. I guess we just weren't brave today. Same side interior. There's a same side exterior as well. And there's another vocab term though. Same side is also called consecutive interior angles, which makes sense. Consecutive means about the same thing as same side in geometry. Consecutive meaning they're right in a row, because they were. And you need to know both terms, just because you never know what the problem's going to ask, what words they're going to use in the problem. Okay, any questions about any of this? You're just epically confused, and you just can't. There are no questions about any of this. Okay, we'll flip it over. I'm going to show you what your homework is, and then we'll keep on going with our lives. I'll probably give you a few minutes for your homework. We got quite a bit of class time left, though. I will give you a few minutes. Just not right this second. Okay. It says color the vertical angles. I get that we don't all have colors at home. Duh. You could do the same way I was doing shapes earlier. You could do shapes. Like you could say angle 1 and his buddy are both the circles. Angle 2 and his buddy are both the triangles. Angle 6 and his buddy are both the squares. You could use shapes or do something so I can tell the difference. But your homework tonight is the back side of this. You do not have to do that maze yet. You just have to color. You just have to color. Okay, I'm going to stop my recording, and then let's go to your notes from Friday that we never got to.